Hello and welcome to this online seminar with the title, The Two Faces of the Scleral Lens. My name is Tresia de Jager, and on behalf of OCULUS, I'd like to thank you for attending this session. Allow me also the opportunity to welcome and thank our special guest speaker today, Dr. Daddi Fadel, all the way from Italy. She's an award-winning optometrist with many accolades. She's a pioneer in the field of modern lens design, a specialist in fitting specialty contact lenses such as orthokeratology and scleral lenses. Dr. Fadel, thank you for taking time to prepare this presentation. We are very excited to learn from you. I think the field of scleral lenses is sometimes very daunting to many of us out there, so thank you. We are excited to learn. Before I hand over to her to start her presentation, just a few technical things. I have with me on the line also Kai Mortis, product manager from OCULUS, and he will be answering technical questions or questions in the background. Feel free to ask questions during the session, and at the end of the session, we will also ask Dr. Fadel. You can write it in the Q&A or chat function. For sound problems, if you have any difficulties, at the bottom of your screen, there's 3 dots, and you can click on those to adjust your sound settings. So with that, let me make you the presenter. Daddi, there we go. And you can start sharing your screen. Yes, floor is over to yours.
Hello everyone, and hello teacher. Thank you so much for this very kind presentation. It's such a pleasure for me to be here to talk about scleral lenses, and today we will be talking about the two faces of scleral lenses. So while scleral lenses are progressively gaining popularity among practitioners because of the wide range of their indication and benefits, there are still several aspects of these lenses that present challenges. Also, each eye is unique and has a unique surface profile and optics. Often, we definitely need a custom scleral lens. The generic lenses can never be an adequate substitute for a custom specialized lens fabricated for each individual eye. These challenges concern both posterior and the anterior surfaces. The posterior surface should align properly on the conjunctival tissue to avoid issues and complications such as blanching, indentation, conjunctival prolapse, midday fogging in the fluid reservoir, air bubbles, and lens instability, lens edge lifting off, causing discomfort of the lens. And the proper alignment only does not ensure success with scleral lens fit. Although the lens is perfectly aligned and offers great comfort, the patient may still complain, and he complains of visual issues. Indeed, the two main characteristics of the scleral lens are high comfort and great quality of vision. Several optical issues may arise as glare, halo, starburst, especially in cases with refractive surgery and advanced keratoconus. So here a customized anterior surface is needed. The customization of an anterior surface optic requires a well-centered lens, thus a perfect alignment with the conjunctiva, and high lens stability on the eye. Therefore, the back surface is crucial not only to align with the conjunctival tissue and avoid problems, but also to allow success in the customization of the anterior surface and for a better quality of vision. Okay, so first discussing the back surface. When is it necessary to customize your scleral lenses? In my opinion, always. I personally personalize all my scleral lenses. Why do I do that? Well, evidence shows that 65.7% of eyes have scleral shape that are different from commonly designed spherical or toric haptic designs. So if you want to well fit most of the eyes of your patients, you need to fit asymmetric lenses, customized scleral lenses. And here you are building an advanced scleral lens practice, which is based on customized fitting lenses. So you need to do that. You need a technology that allows you to map the entire eye and to customize scleral lenses. Another reason why to customize the lenses is because patients ask for advanced technology. Here are some messages I received from patients from around the world who want scleral lenses, but they don't need only scleral lenses. They need scleral lenses made with advanced technology, and they are available to travel to find the technology they are asking for. Another reason to customize scleral lenses is to increase comfort during lens wear. A study has shown that switching from spherical scleral lenses to back surface toric lenses, patients experience overall a better satisfaction, better comfort, and wearing time increased. So the first step in designing a custom scleral lens involves in making accurate digital scan of the shape of the eye. There are different technology of scleral lens customizations. Clinicians must have at least one of these techniques to provide optimized vision and to achieve fitting success and comfort when wearing scleral lenses for their patient. So as I stated before, I customize all my scleral lenses. What I was used to do before is to design the lenses capturing images with the OCT, uploading these images in a software that enables me to design the lenses. I had to take the capture at least in 2 meridians to have at least a toric lens. Of course, this is not sufficient. You need to make several calculations using different formulas for different parameters. And to gain a little bit of time, I developed an Excel sheet to facilitate the calculation. However, even with the Excel sheet, this method is too much time consuming. So scleral lens topographers provide several parameters important for first-line diagnostic selection, and also allows you to send the different to the different labs the scleral topography, so the labs can customize the lens in empirical fitting. What is different with Pentacam is that you have the possibility to design the lenses with a software incorporated. So here is a case of an eye with high refractive astigmatism. The CSP report provides information in 50 semi-meridians up to 18 millimeters. On the angles of the graph here, you can see the area covered, inferior, superior, nasal, and temporal. The colors that you can see in the graph indicate the various quadrants that you can see here on the coverage map. And next you see the corneoscleral topography, and as you can see here in this case we have a high with the rule toricity in the scleral area. And okay, so in the area above you have all the parameters calculated, but before discussing these parameters, let's see how to take the measurements. So Pentacam software guides you in each step. It tells you what you should do. The first scan, it takes the center one, then it's the nasal and the temporal. When taking the superior one, the eyelid should be open wide, and finally the inferior one. In some patients, you have you can see that the low eyelid covering a part of the eye and also the limbus. So in these cases, you need to open the inferior eyelid wide as the upper lid for the superior scan. If the scan is okay, the software informs you about a successful scan. Otherwise, you may repeat it if there is any error or if you think that there is not enough coverage of the eye. So while the CSP report consists of 5 scans, the Pro version is only 1 scan. So it's very easy, it's very quick, modern, and it's very individual for each eye. So let's see the Pro version, the video of the capture of the CSP report with the Pro version. So the instrument focus on the eye and tells you where do you have to go to get focus on the eye. Okay, it directs you on how to position the the instrument, so it captures. It's very quick and very easy. It saves time comparing to the CSP report, the standard one. And it's not now processing, and we will see all the 50 captors in the semi-meridians. And now it will tell you if the scans are okay and how much coverage is done. So we have 100% of the coverage in 60 millimeters of diameter. And then it's done. Okay. It's calculating the parameters of the corneoscleral topography. And here you have the topographical map. Okay. So let's go back to the presentation. Okay, so here you have the cover 100%. In this case, we have 100% coverage of 15 millimeters. Inferior and superior are okay also. So what to do next? Once you have captured the CSP report? If you are used to fit Scleral lenses with diagnostic set, here you have to choose the diameter for which the lenses in your set have their sagittal height calculated. So let's see two examples for sagittal height. Here, let's say that the lenses in your set have the sagittal height calculated at 15.5 millimeters. Here in this area, you have to choose the chord of the lens. The chord of the eye for which you need the information, and the software give you all the information at that chord for the Scleral lens selection, and you can choose the initial central clearance desired, and the software calculate the lens sagittal height that you need to apply on the eye. If the lens sagittal height of the lenses in your case in your set is calculated at 17 millimeter, the measurement of the sagittal height are obviously different in this chord, and also the lens sagittal calculated is different. The lens sagittal height calculated by the software is incredibly important, because it allows you to save to reduce the number of lenses applied on the eye, save time, and avoid stress and anxiety for the patient. From these data, you may also decide for an empirical fitting connecting to an external software. Once selecting the lens diameter in this software and the initial clearance, the software suggests a design based on the corneoscleral topography captured with the Pentacam. To better understand lens alignment, and if you need to make some changes, it's possible to view only the edge in the different quadrants. So if the lens is okay, it's possible to directly order the lens. To know more about the lens design, you can click on the report and notice that here the lens sagittal height, the report is indicated a very highly customized Scleral lens. So in each semi-meridian, not even semi-quadrant, not even meridian, in each semi-meridian, you have different sagittal height, and the tear reservoir thickness is also different. So you have not a quadrant specific design, a semi-quadrant specific design. So it's very, very highly customized. Otherwise, if you want to make changes, it's possible to make the changes. You may need to click and modify the design that you have. You can make the changes in all the quadrants or only in half the lens. And if you want only in one quadrant, you may indicate only 1/4 of the lens you need to change. So you need to rotate the line in the simulated fluorescein here map where to make the changes. Changes may also be done once the lens is ordered and fit. At lens assessment, after 1 week, you notice you need to increase or decrease central volt, you have to change the limbal clearance or lens edge, you may do these changes as well. Customization is mostly needed in cases with high sclerotoricity, asymmetry, or conjunctival irregularities. So, for example, in case of pinguecula, fitting a small scleral lens, the pinguecula will significantly lift off the lens. And in these cases, maybe a larger lens is indicated with slightly compressing the pinguecula. However, when the pinguecula is still high, it will still lift the lens in the periphery, and the patient will experience discomfort. We will have debris entering in the fluid reservoir and sometimes also air bubbles. So with Pentacam software, it's possible to include a localized volt in the lens periphery where the pinguecula is located. You can add it in the graph here, and you can make the changes, and you can see the result here in the fitting simulation below. It's sorry. It's possible also to see it in overview or in edge view to see it better. In the overview lens fitting simulation, you can notice that the localized volt is added only in one quadrant, while in the opposite quadrant, the sclera has a regular landing zone. When clicking over the localized volt, the software provides you the amount of the volt in that area, and you may compare it also with the opposite quadrant where the tear layer is minimal because there is no localized volt included. Okay, so the same thing for other conjunctival irregularities. Customized lenses that align properly are necessary, and in these cases, we are seeing in this also is crucial to have a customized lens to avoid important issue, not only for the ocular surface, but for the entire eye. And here we can see a localized volt, but in the superior quadrant. So you can include these changes in all quadrants that you want. Okay, so we are talking about conjunctival customization. I'm sorry, I was going. Okay, so we are talking about conjunctival customization. What about irregularities compromising the fitting? Like here in this case of Dr. Reef, where a scleral lens with a localized area of an increased elevation is in the peripheral corneal zone. And here we are saying that a scleral lens with a volt in the corneal zone was designed for a patient with Salzmann nodular degeneration. Here is the view of the lens with the localized volt in the peripheral corneal area. The optic section observation showing the clearance in the increased volting area, and the OCT image is showing the volting on the elevated corneal area. So this slide shows the localized volt in the corneal area where the corneal elevation appears. And by rotating the line in all meridians, it's possible to see the lens design, which is different in all quadrants. This video is showing a rotation around the different meridian of a semi-quadrant specific design, showing the presence of the localized volt in only the nasal quadrant. Another customization is in designing oval lenses. It's well known that the HVID and the limbus, the visual, the cornea and the limbus are oval. So fitting a scleral lens based on the HVID, the lens will land near the limbus in the horizontal meridian, while far from the limbus in the vertical meridian, and this will lead to the creation of an excessive clearance inferiorly. And this will cause lens disintegration, stem cell breakdown, prolapse, and also discomfort. And on the other hand, fitting the lens based on the vertical visible iris diameter, the clearance will be optimal vertically, but the lens will touch the limbus horizontally, and this will cause epithelial bulli. Therefore, it's important that the corneal and limbal dose should be designed based on both HVID and VVID, and this will generate an elliptical scleral lens. There are two possible designs for this lens. The lens may be full elliptical with large landing zone in both meridian, allowing a better stability, or make the ovality only in the corneal and limbal zone. And the landing zone here will have different weight in the vertical than in the horizontal meridian. So how to do oval lenses with the software provided by the Pentacam? By moving the red and blue lines, you may reduce the corneal zone diameter and the limbal zone diameter. In all the lens, if you want to reduce, if you notice that it's too much limbal clearance, or if you want it oval, you may change it in the different meridians. Another important feature of the software is that it calculates automatically the lens base curve and the power once you include the reflection in the software. So we talked about both surfaces we are discussing. Now we will discuss the feature of the customization of the anterior surface. Let's see here the case of a patient who underwent LASIK a couple of years ago. As you can see, the visual acuity of the patient is very good, but she complains of halos and starburst, especially at night. Her CSP reports show a significant high asymmetric sclera. Here are her baseline high order aberration profile, which is important to measure and to record, then compare it with the profile measured when wearing scleral lenses. So in this case, we have three options with the scleral lenses. You can fit scleral lenses with standard optics, because generally scleral lenses improve the high order aberration profiles thanks to the tear layer created between the lens and the cornea. Sometimes it's not sufficient, so including a front surface eccentricity may resolve the high order aberration issues. And for some other patients, that still not sufficient, and patients are not satisfied with front surface eccentricity. And in these cases, a customized waveguide front surface is needed. So to this patient, a diagnostic scleral lens with the standard optics was fitted. The lenses were slightly decentered. These were diagnostic scleral lenses, so they were not customized. These lenses were decentered inferiorly in both eyes. With the lenses on the eye, a tomography was performed over the anterior lens surface, and it was noted that the high order aberration, RMS, and spherical aberration slightly decreased, while the horizontal and vertical coma significantly decreased. And the increase of the coma was normal because the lens was decentered. So that's why it's very important to have a very well-centered lens. And to have a very well-centered lens, we need to customize the back surface of the lens. So if you have a diagnostic lens with front surface eccentricity of different values, you may apply them and see which one of these lenses allow better high order aberrations profile. And you can verify it with this Zernick analysis. But you need to be aware with front surface eccentricity, because the diagnostic lenses are not customized fitted lenses, as I already said. And when you add front surface eccentricity, if there is a decentration, we can induce more high order aberrations. and there would be more coma, and trefoil could be worse. And also, you need to remember that some patients do prefer to have to not have front surface eccentricity added. So very careful with the front surface eccentricity. When applying the scleral lens with standard optics, these patients stated that her visual acuity was okay with the over-refraction. She needed the over-refraction, but she was a little bit satisfied with her visual acuity. But she stated that she could still see some star paths. A scleral lens fit, customized scleral lens with front surface eccentricity of 0.6 was applied, and both lenses appeared were centered vertically. However, there was a slightly decentration in the horizontal meridian. Here we can see the results of the high order aberration. We have the comparison between the baseline and with the lens applied on the eye. The RMS has almost halved. Spherical aberration and vertical coma slightly decreased also, and horizontal coma decreased significantly, while trefoil significantly increased in this case. The patient stated that her vision with these lenses was worse with the, when wearing the lenses. So in this case, the best option would be to incorporate a customized wave-guided front surface design. But if you want to include this technology on the lens, you have to have the aberration of the entire eye. Because here we are seeing only the corneal aberration. So to include the wave-guided front surface design, we need the aberration of the entire eye. And here again, the lens should be definitely very stable and well-centered. Here we can see the total aberrometry of an eye that underwent myopic LASIK. Low and high order aberration of the whole eye are measured using the Hartmann-Shack technology. It's crucial to have this baseline information to compare it with the aberrometry profile that we will perform over the scleral lens while it's applied on the eye. And the aberrometry option provides the bar graphs of the Zernike polynomials. It's up to the 6th order of the entire eye optic. And Snellen letter also indicate the quality of vision, and it denotes if the vision is affected by the corneal or the internal aberrations. And the Snellen is very important for us to understand where are these aberrations coming from, but also to show to the patient and let him or let her know that we perfectly understand the complaint reporting hallux and glare, that this complaint is quantifiable, and this is very important in building empathy with the patient, which is very crucial for contact lens success. It's also important to show the patient the aberrometry profile of a normal eye. Also, once the scleral lens with wavefront guided design is applied, it's crucial to monitor the difference between the baseline aberrometry and profile, aberrometry profile and that over the scleral lens. So here we can see how you can show the normal eye is important because you can show the patient how the refractive surgery changes the Zernike polynomials and alters the visual quality. And here we have a full sequence overview of the total aberrometry between a LASIK patient and a normal eye. But again, here, this comparison may be between the baseline profile and after applying the lens with customized front surface. It's important for us, but again, it's important also to show to the patients. So, of course, it's possible to add front surface toricity on the lens. Here you can click on over refraction and you may add the cylinder amount that you have found in the over refraction. To improve stability, you can check also the prism checkbox and to add prism balance to the front surface of the lens. For multifocal lenses, you have the option to design a lens with a center near and center distance, and this depends on the patient needs. Typically, center near is used for scleral lenses and center distance for corneal GP lenses also. And if you click on the front surface curvature map, you can modify the multifocality of the lens as well. Okay, so we talked about lens centration that is crucial for visual outcomes. We know that lens decentration causes a vertical coma, and this is very important to consider, especially in cases who have already coma and the other high order aberrations like keratoconus and post-refractive surgery. Optic decentration is also important for multifocal contact lenses. Here we are seeing the contact lenses from Christine Sint, showing in the first image a decentered lens, compromising importantly her vision. So in this case, she designed a lens decentering the optics. The issue is how to quantify and how to communicate the decentration to the lab. Some Scleral lenses provide a lens with a laser mark, as you can see here, in 8 meridians that helps quantifying the decentration. Also, a recent study presented at the last GSLS introduced a novel method for measuring and constructing the center optics. So here, the software tool compares the concentric circle tool that defines the outer border of the distance, the distance zone with the pupil margin, and calculate the distance in millimeter and the direction in angle of the optical center of the lens. In this case, the optical center of the lens is displaced of 0.50 millimeters toward the 220 degrees relative to the patient's visual axis. So to position the displaced optics over the patient's visual axis, the optical centers must be moved 0.50 millimeter and 100 degrees in the opposite direction. So yes, customization is essential, and different techniques are available to help. We can customize the back surface of the lens with highly customized Scleral lens. We can include localized bolt, and we also can include oval lens. We can have oval lenses, and also very important to consider the anterior surface of the Scleral lens. We need to consider toricity, high order aberration correction, multifocal contact lenses, and decentered optics. Different techniques are available to help with this. Costs may represent a limit, but you have also to consider how much time in optimizing the lens and shear time you will consume to get the final lens, and how much lenses you need to reorder to get to the final lens, and how much money you will spend in reordering the lenses. And in the meanwhile, your patient will get stressed and will perceive in you a non-experienced practitioner, and they would trust another practitioner who have advanced technology, a practitioner who will find faster the final lens, even if the lenses will be slightly more expensive. And remember that patients from around the world ask for advanced technology and would travel to have customized lenses, and are available also to pay more for the Scleral lenses, for a highly customized Scleral lenses. So after all, what I would suggest you to do is to be different. Tailoring the lenses is special and cannot be equally considered or paid as any other lens. So you can try to make your patient choose. You tell them, okay, you have a standard lens and you have customized lens. You explain the difference between these two lenses, and let them choose for the lens that they would like to have. But above all, you have to choose if you want to get to the next step or remain in the basic one. Thank you. And now I left white time for your question and to clarify any of your doubts.
Thank you very much, Dr. Fadel. This was really an informative session, and I learned a lot. There is a few questions for you. One of the questions is, you showed quite a few cases of the specialty cases, if you will. How much would you say is the percentage of cases, specialty cases, that you see compared to normal cases in everyday clinic?
Well, specialty cases need specialty lenses, and the technology are available for both lenses. It depends on the practice that you are building and you have built. My practice is specialty lens, and I see much more specialty cases. So I must say maybe 90% of my patients are specialty cases.
Indeed. A question that was asked is, what would your suggestion or what would your guidance be for someone who wants to start fitting scleral lenses? What's the process, or what would you advise them to start with and do?
Okay, so if you want to start with what you have. Start with the basic. With the basic level, you get to have maybe 2 diagnostic set of different diameters. If you are still intimidated by large diameter, you can have a diagnostic set with a smaller diameter and start fitting with a smaller diameter. Once you have confidence in fitting these lenses, you will notice that larger lenses are needed because they reduce the number of complication on the eye. And once you notice that larger lenses are needed, you notice that maybe the technology you have is not sufficient, and you feel the need to get to the next level. And then you need to have new technology to customize and to get a different lens that properly align on the conjunctival tissue. And I would like to remember everyone that more than half of the eyes, about 67% of the eyes, are asymmetric. So we need, toric lenses are not enough. Quadra-specific design and highly customized lenses are needed, and the more the diameter of the lens is larger, and the more the lens should be customized.
Thank you. Then we have the last question, or there's 2 questions that I'll combine. Is you've shown a lot of your software design. The software is Wave, the Wave software. Is it compatible to use it with the old Pentacams? And also, can you directly, or how is the data from the Pentacam imported to the Wave software?
Well, the Wave software is available for also for the basic Pentacam. You have to contact Wave, and they will provide you the software. Once you have the software, you can schedule also a session with them, and they will explain you all the processes step by step for the lens design, all that you can do with this software. You can design all the lenses that you may have on the corneal scleral topography that you have captured with the Pentacam. You can design ortho-K lenses, corneal lenses, scleral lenses, all the lenses that you need. And also, as the Pentacam provides different options to design the lenses if you prefer also the contact lenses. So you have all the options from soft contact lenses to scleral lenses to have. And yes, Wave again is available with the basic Pentacam.
Thank you very much. That's it. Looks like it from the questions coming in. Again, Dr. Fadel, thank you so much. This is really, it was a very, very good session, and we appreciate it. Thank you for preparing it as well. So from our side, from Oculus, thank you. Have a lovely day and till next time.